Alright, let's do problem 3 in the book. This problem is a great problem because it talks about basically all of main concept 1. It shows you the x center mass equation, and we do it in both the x and the y direction. And it shows you how to deal with the center mass of a uniform object being at its geometric center, and also how the area of a uniform object is proportional to its mass. And it's not a weird circular shape like I was showing you in the notes, so it's a bit more straightforward. So let me try to draw this real quick with the pen tool. You can look along in your book, follow along. So we got essentially this. Okay, that's exactly what it looks like. And that's not exactly. Alright. We got G, and G, 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 something like that. Not to scale, obviously. The y-axis is along here. The x-axis is not halfway down. Like that. X-axis, y-axis. So that the length of this side from here to here is 3L, and here to here is 4L. We got a 2L here, and a 4L here, and a L here, 1L for this piece. This is a 2L here, and this is also a 2L. Of course, this is 2L down here if it's 2L up here. And yeah, that should be good. Alright, so let's talk about the geometric center of each of these. These are all rectangles, so this is a square. So the geometric center is essentially halfway along this side plus halfway on this side, so right about here. 2L over and half an L down. This one is 1L in the middle, and then 1.5 L's down. This is 1L over, 2 L's down, and this is 1L over and 1L up. So those are the 4 geometric centers of each of those, and we're going to use those as our locations of where the point-like object would be. So let's do the x one first. Xcom is going to equal, right, the mass. Well, the mass times the position. Let's do the position first. So the position of, let's do this piece down here first. No, let's do this piece right here. So the x position of the center of mass, as you can see, well, here's 0, 0 right here, right? So we're going over from here this far, which if the length of this piece is 4L, this is halfway, so this is over 2L. So the x is 2L, and then what's the mass of this piece? Well, we're going to use the whole area is proportional to mass, but that only works if it's uniform density. If any of these pieces were more dense than another, we couldn't do this. But so what's the area of this rectangle? 4L times L is 4L squared. Excuse me. So that's for this rectangle. Let's do this one next, right here. Plus, so what's the x coordinate of this center mass? Well, if this length is 2L and the center mass is halfway over, we're only going over 1L. So it's going to be 1L. I'm going to pause and do a throat clear here. You don't need to hear that. Alright, maybe a little better. So 1L, and the area of this box is 2L times 2L, which is 4L squared. Plus, let's do this one next. So where's the center of mass in the x direction of this? This length is 2L, so the center mass is half that over, so 1L. 1L in this direction, that's the negative directions, negative x, so it's negative 1L. And the area of this piece is 4 times 2L squared, so 8L squared, plus center mass is the same here, 2L, so we're over negative 1L. And the area, big parenthesis there, is 3 times 2, 6L squared. Alright, and we're going to divide that by the sum of the masses. So basically this plus this plus this plus this. So 4L squared plus 4L squared plus 8L squared plus 6L squared. So this turns into 8L cubed plus 4L cubed, oops, minus 8L cubed minus 6L cubed all over, oops, 4, 8, 16, 22 L squared. That's going to be, those cancel, negative 2L cubed. So negative 2L cubed over 22L squared. These cancel with 2 of those, so we get negative 2L over 22, or negative L over 22, or L is 5 in this problem, 5 centimeters, so we're going to stick that in there. Negative 5 over 22. Oops, I didn't simplify correctly. This is 11. Come on. Over 11. 2 over 22 is 1 over 11. So negative 5 over 11 centimeters. So most of the mass is over here, which sort of looks like it. So this x center mass is negative slightly over here a bit. Now let's do the y. And we'll just do those real quick. So for this piece, it's this from here to here is half an L, right? And of course from here to here is 2L, because the whole thing is 3 minus the 1. So here to here is 2 plus a half, so that's up. Remember, we're in the y direction, so we're doing how high up vertically are we from the origin. So up 2.5 L. And of course the mass doesn't change, so that's 4L squared still. We can just get it from up here. So I'm just going to go around in the same direction. And this is going to be 2. So if this whole thing down from here to here is 4, 'cause according to this, here to here must be 2, because that's 2. And then half of 2 is 1, so we're down 3. So this is negative 3L times the same mass as before, 4L squared, plus. And let's do this one. This one is down 2. Center mass here is down 2. That was pretty straightforward. So minus 2L. And the mass of this is 8L squared. It's an 8 plus this one's up 1.5 because it's 3, so half of 3 is 1.5. So 1.5 L, and the mass of this is 6L squared. Alright, all over. This isn't changed, so I'm just going to write 22L squared. So that becomes, just to save some time, I'm going to do this real quick. So this is just 10L cubed minus, it's not really saving time, whatever. I'm just going to write it down. You can, if you don't trust me or I screw something up, you can figure it out. L cubed plus 9L cubed over 22 L squared. That equals negative 9 L cubed over 22 L squared. These two L's cancel with two of the three L's here. Becomes negative 9 L over 22. Plug in the 5 for L, so that's negative 9 times 5 is 45 over 22, which is negative 2.05 centimeters, and that is the y coordinate of the center mass. So we basically go over 5/11ths, which is about here-ish, down 2.05-ish, which is like over here. So the center of mass of the whole system is about right there. Alright, so that showed you, just to recap, showed you how to deal with the center, like splitting it up into x and y, how to use areas as masses for uniform objects only, and how each piece can be thought of as, each like sort of segment, each piece of a shape can be thought of as a point particle with all the mass concentrated at its geometric center. So we essentially had 4 point particles that we were thinking of, and those went in here, the locations there, and we did the center mass equations twice, and that was it. Alright, let me know if you have any questions. Next problem.